Let's discuss a question from heat transfer. This is from heat exchanger. So you are given that water is to be heated from 30 to 30 degrees Celsius to 85 degrees Celsius, and oil basically heats up the water, and therefore the oil temperature decreases from 250 to 125 degrees Celsius. And you're asked that if the same thing is done in a counterflow heat exchanger as well as in a parallel flow heat exchanger, and A1 and A2 are the respective areas, then what is the ratio of those areas if other parameters are constant? Now if we use the LMTD method, and why I'm using the LMTD method, because all the temperatures are known. So LMTD method basically says that the heat transfer between the two flows two fluid medium is given by UA delta T LM. Okay, that means U is the overall heat transfer coefficient, A is the surface area, and delta T LM is the LMTD ratio, log mean temperature difference. Now this depends on the calculation for delta T LM depends on the parallel or basically counterflow heat exchanger. So assuming that the flow rate is same, that's what he has given, all the other parameters are same, that means the flow rate as well as the overall heat temperature is same. So obviously the counterflow heat exchanger will take less area. That's what the logic says. So going by this, I can say that Q is U for counterflow, which is denoted by 1 suffix 1 here, is equal to the heat is same, heat flow rate is same, that's what you are asked to assume, and A2 is in the parallel flow. So A1 by A2, which is counterflow by, that's the ratio is asked, is LMTD LM for 2 by delta T LM for 1. That means we need to find out for the parallel as well as, so delta T LM for the parallel by delta T LM for counterflow. It's in the inverse ratio. Okay, so now assuming that it's a parallel flow, so parallel flow, that means both the water and the oil, they enter in the same direction. So if I assume that water is this is the top one and oil is the bottom one, so going by the temperature, water enters at 30 degrees Celsius and leaves at 85. Oil, the direction is same. The oil enters at 250 and gives out some heat, so 125 degrees Celsius. Now how do I calculate delta T LM? Delta T LM is determined as delta T at the exit minus delta T at the inlet by ln delta T at the exit by delta T, the ratio. And what is delta T at the exit? Is the temperature difference at the exit. So that is 125 minus 85 at the exit, that is delta T exit, minus delta T is difference of the temperature at the inlet, so 250 minus 30, and ln, so delta T exit at the exit is 125 minus, so that is 125 minus 85 by 250 minus 30. So same thing, I'll just take the ratio. So this value will be your 40 minus 220, so negative at the top, and here also 40 by 220, okay, minus 220. So it's, the positive, so obviously you have to it's like you can take delta T inlet minus delta T exit, and that minus will go in the numerator, it will just swap it. So that's, so the same thing, minus at the numerator, minus at the denominator will take care. So 220 minus 40, and here it will be in the reverse. So it will be ln 220 by 40. That's the thing. So you can just swap it like ln, if you just take the residue, so minus will be out and then minus goes to the denominator. So this value, if I calculate for the parallel flow, it will be 105.58. So this is for the parallel flow. Now for the counter flow, which I am just drawing it here, so this is my water and this is my oil. So water, assume that it enters like this, and therefore the oil it will be like this. That is how oil flows. So water is 30 getting heated from 35 to 85 degrees Celsius, and oil, the direction is reverse. That's the only thing. The direction in which flow enters is only the difference. So water and oil 125. So now delta T counter flow will be same thing. Delta T at the exit it's 250 minus 85, minus at the inlet it's 125 minus 30, and ln of the same thing, 250 minus 85 by 125 minus 30. So this value comes out to be 126.8, and that's why you got 105 and 126, and you have shown that. Now come back to this. So delta T parallel is 105.58 by 126, the same values whatever we got, 8. So this value comes out to be 0.83. So it's just how do you calculate delta log mean temperature difference for parallel and counter flow. So the areas vary in the inverse ratio, and the answer 0.83 C is the answer for this. Thank you.